paradigm, we have some sort of concepts that go with it. So when we talk about object orientation, we talk about methods and fields, classes, so forth. Likewise, we have some terminology for AOP as well. We have the concept of advice. Advice is just a little bit of code that we want to add to many methods. We have the idea of a join point. A join point is somewhere in our code that we can insert some advice. And then we have a point cut, which is an expression which matches a bunch of places in our code, so we can take the advice and stick it in all of those places. So let's just get more concrete. Here's a little bit of advice. This is the sort of advice which is going to just do the capability check to make sure the user is allowed to do this sort of edit to this blog post. An example of some join points would be these method boundaries, okay? So this one would be like the entry point to the method. This is the exit point of the method. Now, it goes to say that a join point is, this isn't sort of a general thing. A join point is one very specific location in your code. So we could say that this method has 2 join points. And then we have our point cut. So our point cut in this case could be every method entry in our blog data access layer. So what we would do is we'd take this bit of advice and we'd say, I'd like to get it applied to every single method entry that's in this class, and that would be what we end up with. We'd essentially end up with the same effect as if we'd written that bit of code here, but we don't have to write it. We can write it in one place, and we can just declaratively say, please go and put this into sort of my methods where I want it. So if we do that, then what do we win? Well, we've encapsulated a bit of cross-cutting functionality in one place. That's nice. We can also make sweeping applications of new concerns. So imagine that we wrote our system and we didn't really think about logging in advance. We didn't think that we want to log every single method call. And then someone says, oh, we really should have done that. Okay? Now you don't have to go back and find every single method that we need to log and probably miss one by accident and insert the logging code into them. We can just say, oh, I wrote this new bit of functionality here which does the logging. Go and apply it to every single class in this namespace. We can also sort of do some compile time control, and again, it doesn't have to be scattered. So we can say, oh, in a debug build, I want to apply this logging functionality everywhere, but in a release one, then I don't want to at all. So we can actually get that decision made in just one place as well. So we seem to be sort of on our way to solving some of the problems. The only question is how, because C# and VB.NET and the various other .NET languages don't actually provide out-of-the-box support for this. Generally, I think it's fair to say that first-class support for aspect-oriented programming hasn't really made its way into mainstream languages. Perhaps that's because it's relatively new. Now, when I was in Gothenburg yesterday and I said it's relatively new, it's 15 years old or less, a bunch of people kind of laughed. And then I sort of pointed out that object orientation is probably about 30 or 40 years old. So there's quite a difference here. Object orientation appeared in research languages a long time before it appeared in mainstream ones that were being used in the real world. The other sort of challenge that language designers have is to say, well, if we add aspect-oriented programming into the core language, does it actually pull enough weight? Does it solve enough problems for us to have to maintain this functionality in the compiler and have to think about how it interacts with everything else in the language? The other thing is that there's some languages out there where it doesn't actually need to be shoved into the language core because the language is mutable enough that you can introduce aspect-oriented programming in a pretty neat way anyway without doing anything magical. Now, unfortunately, the .NET languages don't tend to fall into this category. They don't really support the whole meta-programming thing. And it's sort of been said by one of the C# developers, like, we're not going to put AOP into the core. So we can't sit around waiting for that to happen. So what do we do? Well, one of the tools that can help us, and this is one of various, is called PostSharp. You may have heard of it. Now, normally when you compile your code, you take the code, you put it into the compiler, and out comes a .NET bytecode file. Now, how many of you have ever read the bytecode file spec? Okay, just me. So this normally happens. So what's in there is actually not just a bunch of code, okay? What's in there is also a load of tables which describe where different methods and attributes are and what classes are in there and so forth. The other thing is that that file is pretty well sort of defined. So what PostSharp can do is it can take it and it can go and twiddle with the bytecode file a bit, so it can go and insert all of these bits of aspect code for us where they belong, and then it just emits sort of what we may call an enriched .NET bytecode. It emits the sort of .NET bytecode that can just go and run on the common language runtime, but it's gone and put the bits of aspect code into all of the places, into the join points that we identified in our point code. At this point, some people say, that's really cool, and some people say, oh no, that's really scary. In reality, it's not so bad, because, as I said, there's a bunch of sort of details in this file that make it reasonably safe to work with. It's not like working with a machine code file. It's sort of a level up, so it's not so bad. And also, .NET bytecode is very well specified. There's a spec out there that anyone can go and grab and read and follow. And also, the VM does some verification. So if you really screw up the transform, it's actually going to go and catch it. So it's reasonably safe to do anyway. And PostSharp has been around for a while, so you've got sort of the sense that it's probably relatively stable and pretty safe. So I just want to take you through a couple of examples of how this looks. If we actually want to do this, then we would add a reference to PostSharp. That's sort of the first step if you want to use this in your project. And one of the things that we'll get when we build is we'll see it's not just added a reference, but it's actually gone and plugged into the build process as well. The first time through, it actually warns us because we're not doing anything with it yet. It's sort of a pointless process. So I wanted to go through two examples. This is the first one. So I've decided that I want to make sure a bunch of things run as a database transaction. So the way we do transactions generally sort of in .NET is we have the transaction scope class and we create it before we sort of invoke the bit of database code, and then we either commit it or we dispose it when the method exits. So what I'd really like to do is not to have to go and write the transaction code all over the place. I'd like to write it once and get it applied to many methods. So the first thing I'm going to do is actually write something called an aspect. So I just pull in the system transactions namespace and the PostSharp aspects namespace, and I write a class. Now, the thing to notice about this class is that it inherits from this thing called onMethodBoundary aspect. Now, when you work with PostSharp, what you're doing when you write an aspect is you're actually controlling the type of join points that you're interested in. So we're saying, we're writing something here that's going to be sort of helping us attach code to method entry and method exit join points in our program. The other thing to notice is that this is called attribute on the end. Okay? Just store a mental note of that and we'll come back to why in just a second. In there, I'm just going to write a couple of methods. So what I can do is I can actually attach a little bit of code, an object to just keep around for the lifetime of the method. So all I'm going to do is say, on method entry, I want to create a transaction scope. So that's what I do on entry. If the method exits successfully, that is, we don't throw an exception, then I'd like to mark the transaction complete. That's going to commit it. So all I've done is got hold of that object I stashed away early, which was the transaction scope, casted it back to transaction scope, and called complete on it. Then, when we're done with that, on method exit, whether we were successful or not, I'd just like to dispose of the transaction. So if we didn't complete successfully, this will at this point do the rollback. So we've said what we're going to do on entry, we've said what we want to do on success, and we've said what we want to do on exit. So we've specified some advice to go to a whole bunch of join points. So now we've done that. Now you'll remember that we had the word attribute in the class name. Well, the reason we had that is because then we can actually just apply this as an attribute using the C# attribute syntax. So here I can just apply this aspect to my one method. I can say I want this one method to have sort of transactional semantics. I want to have it as if I wrapped it up in this transaction. Alternatively, I could say every single method in this class should get this transaction scope. So that will just go and apply it to every method in the class. And if we sort of go and look at the sort of list of places we can apply these attributes, you'll see that it will actually go and apply them sort of in a very broad sense, depending where we put the attribute. Now you might be wondering why field and parameter in here. There's actually a bunch of other things and join points where you can sort of intercept in your program. So there's quite a lot of sort of flexibility there, which I just can't really address today. But you can go and look all of this up. But anyway, the main thing to take away from this is that there's a lot of places that you can go and put your sort of advice into your program. So for my second example, I'd just like to show you a different kind of advice. So in this case, instead of writing this, so all I'm doing is getting the thread pool, the .NET thread pool, and I'm just going to stick an item in it so that instead of this being a synchronous operation, we just fire it off and forget about it. Okay, so that we're just trying to make a synchronous operation, which is saving something into an asynchronous one, so we don't have to sort of wait for it to finish before we do something else. So what we might do is just go and write this, which isn't too much code, but we might decide that instead we'd really like to just write something like this. We'd just like to add do this on a worker thread. And then whatever we do in that method will sort of get executed on a different thread. Now, the problem with this is it's not quite the same as what we did last time. We don't want to do something on exit and entry and so forth. It's almost as if we want to wrap the whole method up and sort of put something around it instead. Well, we can do that. It's just a different type of join point that we need to identify. And this is called the method interception aspect. So what we're actually using as our join point here is the point that the method is called. And what we're going to do is instead of doing some sort of work before and afterwards, we're going to completely intercept the call. We're going to wrap it around what we want, and then we're going to go and continue with what we would have done anyway. So if I look at how this looks, all I do is just say, I want to do some work when the method is invoked. I'd like to do my thread pool operation, and then instead of the code that I want to have, if we go back here, okay, you can see that this is the little bit of code that we wanted to do. So this.contact.save. Here we say, this is the point where I want to proceed and run that code. And you'll notice this is a delegate, it's a Lambda expression here. So all we've done is just gone and sort of made our thread and then said, go and do what you would have done anyway. Go and do the call, but within the thread. So we've sort of wrapped up our bit of work inside a call into the thread pool. So that's PostSharp. Now, it's good to sort of know that that's just one tool. It's probably one of the most popular ones in that sense, but it's not the only one out there. If you are working with an inversion of control container or a dependency injection container, then some of them, as well as doing dependency injection, actually try and provide some support for something a bit like AOP. Now, one of the things they tend to do is they can do things like taking your class and actually wrapping it up in what we call sort of a decorator. So what you end up with is, instead of having an object with the methods in it that you want to call through your interface, you end up getting an object which does some maybe behavior before or after, and then calls the original method. Is this really AOP, or is it just a decorator pattern with some tweaks? Well, that's kind of a good question. My sort of own feeling on this is that this is valuable. This is something that's kind of nice, but it's not really full AOP. It's sort of not the whole answer. Another tool, if you sort of want to do some more real AOP, is you can go